Hello and welcome back to Physics Safari. My name is Abhishek and today I'm gonna discuss with you the differentiation. I'm sure you guys must have seen the previous videos where I've taught in various basic mathematics as in trigonometry, the sort of expansions on the binomial theorem. I've also discussed with you about the functions, about the graphs, especially the parabola, quadratic and stuff like that. If you have not seen the video, I'm gonna give the link in the description. Do watch that before coming to this lesson. Okay, so today's we are into the lesson 4 of this basic mathematics. Already 3 videos has been made on this. Already 3 class has been recorded on this. So yesterday I have discussed about the slopes, lines and parabola. All good. Now let me just help you to understand one thing. For example, let's say I have a certain graph, maybe random graph, anything like that, and x-axis, and here we have the y-axis. Now let us say if I change the value of x coordinate, as in at this particular point, let's suppose this is your function f of x, or that is equals to y, this is your function, any random function. I've just chosen that. At this point, let's suppose x is equals to a we have. Corresponding to this value of x equals to a, I'm going to get some value of the function, that is the value of y. If I move from this place to, let's suppose, x equals to b over here, then for this particular value of x, I should be getting some value of y. Let's suppose y dash, and this is your y. What is happening? With change in x, so let's suppose I represent that with delta x. With change in x, I'm actually going through some change in y. All good? Now, so I can say that there is a change in y when the x is changing. So there is a change in y with respect to x. So that could be written as a rate of change of y with respect to x. If I want to write it up across that way, then that should be written as delta y upon delta x. So this is on an average when x shifted from a to b, the change was y dash minus y. So I can say that should be equals to how much? Y dash minus y upon, or maybe I can choose y1 and y2. That would be a better way to represent. So y2 minus y1 upon b minus a, which is x2 minus x1, you can write. Now, this is for a certain value. B and a are the significant values. They have certain value. They are not very close by, and the difference between them gonna be some significant value. Now, let us say I reduce this gap of a and b to a very small distance. Maybe I would say to a very small distance, maybe here. I should say, okay, let's suppose this is x, and small change in x is measured. Let's suppose delta x. For that small change, and we're gonna go through some small change in y. So here, if it is y, then this is going to be how much? Delta y, small change in y. So with respect to small change in x, we shall be having some small change in y. So I can write as rate of change of y, rate of change of y with respect to x over here. I can say dy by dx, delta y by dx. Okay. Now, let's say y is equals to, if I say there is a function f of x, with small change in y, can I just add y plus delta y? That should be f of x plus delta x. That should be the case, right? Because if it is f of x, if I assume this to be f of x, some value, then this is going to be how much? F of x plus delta x. All good? So y, I write f of x, then y plus delta y, that is this distance, I should be having f of x plus delta x. That means delta y should be written as what? F of x plus delta x minus y. What is y? F of x. So I can right away say this is equals to f of x over here. I'm actually interested to find the rate of change of y with respect to x. So let me divide both the side with delta x by delta x. That should give you how much? Delta y upon delta x, and that is going to be equals to f of x plus delta x minus f of x upon delta x. Well, this is going to give you some average change for a significant value of x. This is going to be the value of change of y. So this I can call as average change. Average change. If I make this value a very small value, if I make this delta x almost tends to 0. So here comes the concept of limits. So if I make this value almost tends to 0, then this becomes very small, and even this would become very small. So now I'm going to have small change in y with respect to small change in x, and that small change could be taken as an instantaneous change. Why I'm saying that? If I, let's suppose, if I make it almost close to 0, then this delta x would appear as a small point over there. So with respect to this small point, we should be having a small change over here in the y. So this becomes an instantaneous one, exactly at this particular point. All good? So if I put the limit, let's suppose limit delta x tending to 0, that is this value is tending to 0, then this should be written as what? Probably I would just write this delta y upon delta x. So I'm going to apply limit on this side also. So limit delta x tending to 0, f of x plus delta x minus f of x upon delta x. Now this is the instantaneous change of y with respect to x. So we can represent this as dy by dx, and that would be given as limit delta x tending to 0, f of x plus delta x minus f of x upon delta x. So this is the derivative of the function y with respect to x. So derivative is an instantaneous change. It's also given as instantaneous. Instantaneous. This is the instantaneous, and when we have this one, that is called the average. So from here only I can get the concept of average velocity and the instantaneous velocity going further in the next topic. So I'm going to be using these two. Keep that in mind. So if I want to find the differentiation, so that is how we're going to find. Also, I want to add one more thing over here. So basically at this particular point, if I want to find the slope of the tangent, so let me draw a tangent. So for this particular point, can I say the tangent would be dy by dx? Let's say quickly small draw I draw. This is how much? Delta y, and this is going to be how much? Delta x. So I can say slope would be given as limit delta x tending to 0, delta y upon delta x. So slope is also achieved by differentiating the value of function with respect to x if it is y and x. So this instantaneous is also called as slope of the function. This gives the birth to the derivative. This is also called derivative of y with respect to x, and from here we get some basic rules of differentiation. So all good, my students? So here we have, let me just try to make a relation with this and the differentiation. So I'm sure you guys have noted it down. All right. So let me just erase this. Okay, here we have. So let me just erase this one, and let me show you a couple of fundamental stuff about the derivatives. All right then. So derivative essentially means rate of change of quantity with respect to the another quantity. If I'm talking about precisely about y and x, so it's going to be the rate of change of y with respect to x. Let's say I have a function, probably y is equals to x square. Okay, let me write it properly. I want to find what is the instantaneous rate of change of y with respect to x. I want to understand the instantaneous rate of change of y with respect to x. So for that, what I'm going to do, I know that, so dy by dx should be equals to what? Just now we have seen that is going to be limit delta x tends to 0, f of x plus delta x minus f of x upon delta x. All good? Now, what is f of x? This is your f of x, right? You can just for your convenience, f of x. I would write this as how much? This could be written as limit of delta x tending to 0. F of x plus delta x means this could be written as x plus delta x whole square minus f of x, which is x square itself, upon delta x. Let it be. Now we can expand this using a plus b whole square, that is a square plus b square plus 2ab. So limit delta x tending to 0, this becomes x square plus delta x whole square plus 2 times of x times of delta x negative x square, and we should be having delta x over here in the denominator. Now this x square would get cancelled, isn't it? That would just leave you with limit delta x tending to 0, x delta x whole square plus 2 times of x delta x upon delta x. Why don't we just put the value of delta x as 0? If I do that, I'm going to get what? 0 plus 0 upon 0. That means it is going to give you 0 upon 0, which is a not defined form. This is an undefined format. So over here, just to sort of get it done, I can take the delta x common. So I should be having limit delta x tending to 0. Let us take delta x common. That would just leave you with delta x plus 2x, and down also will be having delta x, which later can be cancelled. Now if you put the value of delta x as 0, because delta x is tending to 0, it's not the exact value, but it is approaching 0, so almost we can take it as 0. So if I put 0 over here, you should be getting how much? 0 plus 2 times of x, that is going to be 2x. Okay, so this has actually brought me to a situations where I can say that d of x square upon dx, that is going to be 2 times of x. So this is all about rate of change of x square with respect to x, well, that is 2x, and this is called differentiation. So one fundamental rule of differentiation I'm going to give you. So this is called the differentiation. So in maths, you will study this in detail. How do we reach out to this thing? And you will also get to know over there in the maths. I'm just telling you, limit x tending to a, x to the power of n minus a to the power of n upon x minus a should be equals to n times of a to the power of n minus 1. And this is a fundamental rule of differentiation, which you will study in the topic limits in the maths of class 11. But anyways, for the concern of physics, I will just tell you a couple of rules that you should be knowing. So if I have d upon dx, the very fundamental rules of differentiation, this is going to be n times of x to the power of n minus 1. This is a fundamental rule of differentiation. So basically we have understood that differentiation is all about finding the rate of change of one with respect to another at a particular instant. So this is a instantaneous rate of change of a variable with respect to another variable. Okay, having seen this, a couple of examples we can take. So let's suppose, for example, if I have to differentiate, let's suppose x cube. So x cube over here, that should be how much? If I apply this rule, n is 3, I'm going to write 3 here. X as it is, n minus 1, that is 3 minus 1, so that should be how much? 3 into x to the power of 2. That is how we do the differentiations, my dear. All good? Now let me just write a couple of rules of the differentiation for you, so that would be easy for you when we use it in topics of physics. It should not be completely blank over there. Anyhow, you are going to study all this stuff probably in the 11th maths towards the ends, after limits, derivatives and all. But majorly we will be dealing with this in class 12 calculus. Few fundamental rules of differentiation. Number 1, as I've written that one. Number 2, if I have a constant, so differentiation of a constant, let's see what's going to be. So differentiation of a constant has to be 0. Reason is, a constant does not change with respect to x over the period of time. If you increase the value of x, I have a, let's suppose I have a point 5 over here. Now this 5 is not changing. Even if I increase the value of x or y, the 5 will not change no matter what. If I look at 5 at today morning or maybe evening, the 5 will remain 5. But let's suppose if a body is moving and I'm trying to find the distance, and if I look at the particular time and a certain other time, the distance would be changing. The body would have moved certain more distance. So that changes, but over here it's a constant. So the derivative of a constant is going to be 0. Now we have derivative of exponential function, d upon dx of e to the power of x, that would remain as it is. There is no change as such over here. Now let's suppose if I have some functions like d upon dx of a to the power of x, This is going to be log of a times a to the power of x. This is how it is going to be. Okay. Also, if we have something like negative power, don't worry. If I have x to the power of minus n, well, that should be negative n times of x to the power of minus n minus 1. Well, just to consolidate this more, I'm going to take an example. If I have to differentiate d upon dx of x to the power of minus 4, well, I'm going to use this one. So, probably, okay, just, minus n over here, the entire thing. Don't get confused with minus and then putting minus 4. No, entire thing. This entire thing I've written over here. This is going to be negative 4 times x to the power of minus 4 minus 1. All good? So, it's going to be how much? Negative 4 times x to the power of minus 5. Well, that is the answer. Likewise, if they give you, 1 upon x square and we have to differentiate this. Well, again, not a problem. You just need to put this as in this format. D upon dx of x to the power of minus 2. And the same rule, minus 2 times of x to the power of minus 3. All good? Okay, one more I would just like to tell you. Let's suppose maybe here I would write differentiation of log of x. D upon dx of, if you have any logarithmic function, that is going to be 1 upon x. That should be 1 upon x. Make a note of these derivatives. These are going to be commonly used. Now, let me help you with some trigonometrical derivatives. Let's suppose number 6. Differentiation of d upon dx of sine of x. That is going to be cos of x. Differentiation of cos x, d upon dx of cos of x. Well, that is going to be minus sine of x. And therefore, the last one, d upon dx of tan of x. That is going to be sec square x. More derivative, if we need, we're going to discuss. But one thing I would like to add over here, let us say in some cases, if you've been given as d upon dx of sine theta, please do not write this as cos theta. This is wrong. The reason being, I have not mentioned if theta is a function of x or not. As of now, they are different things. If theta is changing or not. So, if to write it correctly, this has to be written as d upon d theta of sine theta. Now, this is going to be correct if I write cos theta. This is the correct one because the function has to be this. As you can see, with respect to x, we have over here, so it was okay. But when we have different things, but for that also we have a various rules. I'm going to discuss in the later part of this video. Okay, so we'll restrict ourselves to these fundamental derivative. Rest you can find it anywhere, and if it is required, I myself going to help you with that. Now let me help you with some fundamental rules of derivative. Let me help you with the fundamental rules of derivative. How do we go about solving the question? Let's say, for example, if I give you one question, let's say example. If I give you y is equals to maybe 4x cube plus 2x square minus 6x plus 2. And I ask you to find dy upon dx. Now, you need not worry. You treat all of these as a separate or identity. So, you can differentiate them, one of each of them one by one alone. For this one, that should be, okay, now you might be having, so there's a constant, what to do about this? Okay, to add to that, if I have a function y is equals to a times of, let's say, x square. It is a constant which is multiplied with a variable. The constant is not alone over here. So, in these cases, if I want to differentiate, let's say, dy upon dx, you can take this sort of the constant outside and you differentiate the variable. That is how the things has to be taken care. And this is going to be 2 times of x. So, final answer you will be getting is 2ax. So, whenever we have a constant coming up along with the variable, you take that out of the derivative and you differentiate the variable. That would be all. So, following that stuff, I'm going to be having how much? 4 times 3, 12x whole square plus 4 times of x minus 6, and this being constant should be 0. Yep, all good. Now, likewise, we can actually, maybe we can just look for one more example just to help you to understand. Let's suppose if I have y is equals to maybe x square plus 1 upon x square. Now the reason why I'm taking these many examples just to make you comfortable with the derivative, because you will be studying this stuff in maths in the later part. Especially for those who has taken the biology, they will not be studying, so for them it's going to be more crucial. So let's say dy upon dx. So here I'm going to have this as separately 2x. Now this one you could write this as what? X square plus x to the power of minus 2, and then in that case that is going to be minus 2 times of x to the power of minus 3, which you can write in terms of fraction as 2 upon x cube. Not a big deal. All good? Now let's have one more example. If I say y is equals to root of x, because this is commonly used. This is something which you will get quite oftenly. So in that case, this could also be written as what? X to the power of 1 by 2 without any hesitations. So dy upon dx, that should be 1 upon 2, x to the power of 1 upon 2 minus 1, that's minus 1 upon 2. So dy upon dx should be how much? 1 upon, if I take it down, I'll be having x to the power of 1 upon 2 in the denominator. Well, that should be easily written as 2 times of root x. And trust me guys, you can just memorize this. It's not a big deal, and because it's going to come to you quite oftenly. So if you have it in mind, the process would be faster. All good? Okay. So now note it down. Also, if I just erase this one, also they can ask you to find the tangent. They would give you the equation of the sort of function, and they would ask you to find the tangent. So let's say, for example, if I give you y is equals to maybe x square plus 3x plus 4, and I ask you to find slope at slope of tangent, you can see slope of tangent to the curve, slope of tangent to curve at point let's say 1 comma minus 2. You can choose that way. We know that its derivative is all about the slope of the tangent to the curve at that particular point. So first of all, what I'm going to do is I'm going to differentiate this. So dy upon dx should be 2 times of x plus 3. Well, that is nothing but the slope. At which value? Just a random x, right? So if I want to find the slope at a specific value, which is 1 comma minus 2, so slope of the function at 1 comma minus 2, I could write as what? 2 times of 1 plus 3. There is no point using the y over here. That's going to be how much? 5. So slope of this tangent of this function at any point, let's say 1 comma minus 2, should be given as 5. Now, this could be at any random point. They can choose this as any point, and the process is going to remain same. There is nothing that would change over here to find the slope. All good? Now, also, it's just not like that only x would be there. We can also have variables. Maybe it could be t, could be probably m, or could be anything. Okay. So let me show you one example that way. Okay. So if I say I have an example, y is equals to maybe 4t square plus 2t. I want to differentiate this with respect to t because y over here is a function of t. So the independent variable is t. So the value y would change only with respect to t over here. It means I have to differentiate this with respect to t. The entire process is going to remain same. Please don't get mistaken that only dy upon dx is the derivative. No. It's all about rate of change of one variable with respect to another variable. So what if I have the graph of, let's suppose this, probably this is your y and this is your t. And this is a parabola for sure, it's going to be not parabola. So we're going to have over here something like probably any graph. It's a cubic thing. So the graph is like this, let's suppose. In that case, what we're going to do, I'm going to find, okay, it's going to be a parabola. It's a quadratic, so it's going to be a parabola. So let's suppose something like this. Let us find dy upon dt. It's a quadratic, so yeah, it has to be a parabola. This is going to be 8 times t plus 2. Well, that is going to be the slope at any point. So maybe if I want to find at this point, this is going to be tangent, and we can find the slope. All good? Now let me help you to understand few rules of the derivative. Already we have seen the basics derivative, and we have done few examples. I'm sure you guys must have got an idea of this. You can actually pause the video now and you can just frame some of your questions on your own and do that. Or else you can practice from some books for the derivatives. Anyways, now one rule I'm going to tell you, that is called the product rule. Product rule. As in, if I have y as multiple of two functions. So let's suppose if I say x square times log of x. You can see that y is written as multiple of two functions, two variables in x. So in this case, how to differentiate this? The idea is very simple. You have to take one as u and other as v. What next? If I've taken u and v, what next? So for that, the rule that I'm going to tell you is d upon dx of u times v, where u and v are the functions of x. U and v are very important to mention, because if I'm differentiating with respect to x, there has to be the function of x. So when I say function of x, what exactly it means? It means they are dependent upon x. The change in x will bring some change in y, sorry, u and v. That means they are the function of x. So how to do this one? This is going to be, you can keep u as it is, you just differentiate the second function, and next time you keep v as it is and you differentiate the first function. So this is your product rule. All clear? So what exactly I need to do over here? So dy upon dx is going to be, I'm going to keep it as it is. So maybe x square I can keep as it is. I'm just writing d upon dx of log of x plus, this time I'm going to keep log x as it is. So log x, and we'll have the differentiation of x square. Now this is going to be how much? X square. Derivative of log x, just now we have seen, is going to be 1 upon x plus log x being as it is, and derivative of x square is going to be how much? 2 times of x. Well, that's your final answer. You can just cancel it up. You will be having x plus 2x times of log x. Yeah, that is your answer. So whenever you have multiples of two things, you can actually try and do it. All good? Let's have one more example just to make it more clear. If I have y is equals to e to the power of x, maybe sine of x. Again, you can see I have two functions, ex and sine x. So dy upon dx will be how much? You keep this one over here and you differentiate sine x, that is going to be how much? Cos of x. Now you keep sine x as it is and differentiate e to the power of x. That is going to be e to the power of x itself. So that is your final answer, my dear. All good? Now let me head towards the next rule, that is called chain rule, or maybe you can understand that way with some examples. That is called chain rule. That is called chain rule. So the next thing is the chain rule. Now what exactly does it mean? Okay, so let's suppose if I write a function, y is equals to log of sine of x, and this sine x is inside the log. So these are not two separate functions, but it's just like we have one function related or inside the another function. So these are the functions which we need to do, which we have to solve using this rule. So what exactly we do in this? Very simply, when I want to differentiate, let me help you to understand this with an example. I would be going from left to right side. That's how I do. So whatever function is falling in the way, I will keep differentiating, keeping others as it is. So this is my first function, which is log function, and the sine function is the second function for me. So first of all, I'm going to differentiate the logarithmic function, and we know d by dx of log x is 1 upon x. So this is going to be how much? 1 upon sine of x. Multiplications. I'm going to now differentiate the second function, which is sine x, and derivative of sine x is how much? Cos x. So ultimately cos x by sine x is going to be your cot x. Simple as that. So this is called the chain rule. Also, you can have one more example. Let's suppose if I have more than two functions, then also this is valid. For example, if I say y is equals to maybe sine of log of root of x. If I have this, see, over here I would be actually having three functions. One is your trigonometrical, logarithmic, and the algebraic. Now this, if I would have had just x, then even if it is present, but derivative of x becomes 1, so we tend to neglect that. But over here, derivative of root x is not 1. So we have to consider that as a separate one and we have to work on that. So here we have what? dy upon dx is going to be, first of all, let's start from this side. I'm going to differentiate. So we're going to be having what? Sine will become cos and everything else would remain as it is for now. No change in this thing. Mind it, okay? Did not change anything over here. When you derivative the differentiating the first function, do keep that as it is. Now, when I say first function, let me first label it. First function, second function and third function. That would be more clear for you to understand. So, cos of log of root x into the next one, I'm going to target the log. Differentiation of log is 1 upon x. So, this is going to be 1 upon root of x. Multiplication. Now, finally, this is what we're going to do. Just now we have done, its derivative is going to be 1 upon 2 root x. Finally, you can simplify this one. So, it's going to be having what? 1 upon 2x cos of log of root of x. And that's going to be your final answer, my dear. So, this is called as chain rule. This is called as chain rule. Now, the last one is the quotient rule, where we have something in division. Let me help you with that. And this chain rule is going to work out quite handy to you in various cases. Now, let's suppose a quotient rule. The quotient rule says, if I have y as a function of u upon v, where again u and v are both function of x, in that case, dy upon dx, my dear, should be written as this. You keep the v as it is, you differentiate the numerator part, du by dx, minus, you keep this numerator part as it is, and you differentiate the denominator part. So, this is how it's going to be, and divide by v square. This is called quotient rule, where we deal with the functions in which we have something in the division form, in the fractional form. Okay, let us have an example to understand this. That would make it more easy. If I have, let's suppose, sine of x upon maybe x, I would like to differentiate this. So, this is in the form of u by v. I'm going to use the quotient rule. So, here we have dy upon dx should be v. Keep it as it is. Differentiation of u, which is sine x, that is going to be cos of x. Put a negative sign. Keep the sine x as it is. Do not change anything over there. And differentiate x. That's going to be how much? 1. Okay, if you have not understood how the differentiation of x becomes 1, here it is for you. Let's suppose y is equals to x. I could see this y as x to the power of 1. Applying the fundamental rules, so I'm going to have dy upon dx should be what? N, which is 1 times x to the power of n minus 1. This is going to give you 1 into x to the power of 0, which comes out to be 1. That's it. So, derivative of x is going to be 1. And in the denominator, we'll be having what? X square. So, that is how we do the differentiation of the function which is present in the u by v format. Okay, let us take one more example. Let's take one more example. If I say that y is equals to x square minus 1 upon x square plus 1, or maybe you can choose this as 2x. In this case, dy upon dx should be, I will keep the denominator as it is, would differentiate that would be just 2 minus, I'm going to keep the numerator as it is, and I'm going to differentiate the denominator, which is going to be how much? 2 times of x upon the x square plus 1 and whole square. Well, that's going to be the derivative. Rest you can simplify. All good? That is the fundamental thing about the derivative. Now, let me just tell you one more thing. When we have functions which is dependent, multiple function which is dependent on a single function, how do we do and what do we do in those cases? So, with example, probably you'll be understanding it in the better way. Let's say that I have two functions, maybe u as x square plus 2x, maybe v as x cube minus maybe 4x. As you can see, both u and v are the function of x. U also is a function of x, whereas v is also the function of x. Both are the functions of x. This is the way to represent the function of x. Now, let us say that I want to find probably du by dv. In this case, what I'm going to do? Look, u is not the direct function of v, but they are related to a channel which is x. They are related with the link of x. So in this case, I can actually differentiate u with respect to x, because that's how we can go with, because u is a function of x. Now, if I do write like this, dv has to be in the denominator. Let's say dv, and you put dx over there. So basically, what are you doing? You're just doing that du upon dx sort of dv upon dx. That's it. And you can see if you simplify, dx would get cancelled and you'll be having the same thing what we have. So the idea is very simple. You're going to differentiate u separately and v separately, and you're going to put it here. That's all. Nothing much. No differences at all. So first, let us find du by dx. That should be how much? 2x plus 2 equation 3. I would just put, just to ensure we don't miss out on anything. And here we have dv upon dx. That should be how much? 3 times of x square minus 4. Now, I'm going to replace this over here in this equation. So du upon dx, that should be 2x plus 2, and here we have 3x square minus 4, and yes, that is your answer, my dear. So whenever you have this kind of cases, this is how we have to approach. There are going to be various cases. For example, let's say I say that s is a function of t, maybe t square minus 2t, and maybe probably I can say y is a function of t again, maybe 2t, something like that. And I want to find dy upon ds. Alright, we're going to do the same process. I'm going to find dy upon dt, because y is a function of t, as well as x is a function of t, upon, you can say, ds upon dt. We'll do it and we'll just substitute it over here. Not a big deal. So dy upon dt should be 2, and ds upon dt should be how much? 2t minus 2. You take the 2 common, you will be having t minus 1. Well, that is your answer, isn't it? So yeah, that's the basics of differentiation that you guys need. Going further, I would just capture the maxima and minima now, because that is something which we need in the physics. So you practice till on the differentiation, you practice till here, and then in the next class we'll talk about the maxima and minima. All right, and also watch the previous video just to ensure that your basic mathematics is clear. All good? Till then, keep learning, and do like and subscribe, and don't forget to hit the notification icon so that you can get all the latest updates of my updates. All good? So yeah, thanks for watching, guys. I'm gonna see you later. Take care. Bye bye.